Okay, so the purpose of this video is to go over the solutions to the problems you encountered in Bell Work number 1, which addresses how to factor binomials. So if you look at problem number 1 is a special case. We have a...
Okay, please transition B lunch back to 4 o'clock block. B lunch back to 4 o'clock. Thank you.
We have a difference of squares. And remember, if you have a difference of squares, then it can be written this way: a squared minus b squared. It's called a difference of squares because we are subtracting, right? Subtract means difference. And of course, squares because the exponents are raised to, the exponents are powers of 2. And if we want to factor a difference of squares, all we do is we take the first base plus the second base, and we multiply that by the first base minus the second base. Now this formula only works if you have a difference of squares. And if you look at number 1, we do have a difference of squares because 36 is actually 6 squared. So that's going to be x squared minus 6 squared. Now, after you've done these for a while, you probably don't have to write that step. Most of you probably recognize a square when you see one, but if not, you may still have to write it out where you can actually see the base. So the formula says when you factor it, you take the first base plus the second, first base minus the second. Well, the bases are x and 6. So this can't be the answer. This cannot be the answer. This one cannot be an answer because the signs are the same. And if you're factoring a difference of squares, it has to be first base plus the second, first base minus the second. So x plus 6 times x minus 6 is going to be our solution. Number 2, what do you call a polynomial that cannot be factored? Well, let's look at the options. The FOIL method is what we use to multiply binomials together. First, outside, inside, last. So that's not correct. A polynomial that cannot be factored is not necessarily simplified, so that's not correct. Proper is not correct. So if you cannot factor it, then it is prime. A polynomial that cannot be factored would be prime. Let me give you an example of a polynomial that is already in simplest form, can't be factored. If you have, let's say, x plus 1. Well, there's nothing you can factor out. There's no GCF for any of these terms here. So that would be prime. Let's look at problem number 3. Problem number 3 is also a difference of squares because we know that 49 is really 7 squared. So I'm going to call 49 7 to the power of 2. And it is a difference because we're subtracting. And it's going to be first base plus the second, first base minus the second. So it appears to me that x squared minus 49 is going to be our solution. Is it possible to check? Could we multiply x plus 7 times x minus 7? Absolutely. We could FOIL this to check. Let's do that. If I multiply, let me clear some things out here. If I multiply x times x, those are my first terms, that gives me x squared. And next, I have to do the outside terms. That would be negative 7 times x, which is negative 7x. Then we have to do the inside. Well, positive 7 times x is positive 7x. And finally, we do the L in FOIL, which means last terms. That's going to be a positive 7 times a negative 7, which ends up being negative 49. Okay. Notice that the negative 7x plus 7x, so that just becomes 0. And that leaves me x squared minus 49, which is the original problem. So we did factor it correctly. So we use FOIL in order to check our work, typically. Okay, let's take a look at number 4. On number 4, this cannot be a difference of squares because I have a plus sign. This would be a sum, so it's not a difference of squares. So what I'm going to do is I'm going to see, is there a number that goes into both 6 and 16? In fact, I want the biggest integer that will go into both 6 and 16. Well, 2 goes into 6 and 2 goes into 16, and that will be the biggest integer. But I can also see that this factor has m, and this factor has m times m, right? M squared. So I can factor an m to the power of 1 out. That's going to be the greatest common factor. And now I simply divide. Or I can look at it this way. What would have to go in the first position here that would multiply by 2m to give me 6m squared? Well, that would have to be 3m. And then, since it's a plus, I will put the plus sign. And then 2m times what entry in the second position will we need to get 16m? Well, 2m times 8 would give you 16m. So the factored form is going to be 2m, open parentheses, 3m plus 8. So it looks to me like our answer has to be here. So hopefully you got that one correct as well. And let's move right along, look at numbers 5 and 6. Problem number 5, we've got, we have a 1 here, and we have a negative 14 here. And the biggest number that goes into 1 and 14 is just 1, so that's not a problem. I have a p squared and a p. I can take a p out. And that's going to leave me in parentheses p minus 14. Because, let's see, p times p is p squared. I have the minus. And then 14 times p, that would give you 14p. So that does check. So the answer appears to be number, this one here. Now, problem number 6. On problem number 6, I have a 1 here and a 4, so that's not going, okay, so the biggest integer that goes into 1 and 4 is just 1, so nothing to take out there. I do have an x cubed and an x, so I will take out an x since it's common in both terms. And x times what value would give me x cubed? Well, that would have to be x squared, right? Minus 4. And let's check that. X times x squared is x cubed. I carry the minus, and then I multiply x times 4, and I get the 4x, right? So it looks to me like the answer to that one has to be, we have a problem here, kinda. Notice that this is actually a difference of squares, right? Because 4 is 2 squared. So let me rewrite that so we can see it more clearly. I've got a 4, but 4 is 2 squared, right? It's 2 to the power of 2. And we know that in order to factor a difference of squares, right, we take the first base plus the second base, and we multiply that times the first base minus the second base. So always be on the lookout, because sometimes after you factor, you may realize that you have to factor again. And it looks to me like the solution has to be this one here.